We've spent the morning looking at the how of AI, the cooling, modular builds, and the power resilience. But to truly scale at the pace the market demands, we have to look at the why and the who, specifically for the investors and the ESG mandates driving the capital. For our next guest, we have a perspective on data center infrastructure. She has expanding over 30 years in project finance and ESG strategy. Sayuri Moodliar has led ESG functions for major providers and advised at the highest levels within KPMG and PwC. She understands better than anyone how sustainability has moved from a compliance checkbox to a more core commercial imperative. So Sayuri, it's a pleasure to have you here. So let's get this started.
Thank you. Thanks for the opportunity to chat about my favorite topic.
Of course. Would you like to give the chat a little introduction of how you've done it, what you've done in the past?
Yeah, sure. So, I mean, as you said, I've been in infrastructure project finance for a few decades, and starting out in consulting and working in a variety of industries. Most recently, I led the ESG function at Open Access Data Centers in the Wire Group, and worked a lot with advising and on transactions with our investors, and particularly with the hyperscale clients as well.
Fantastic. Perfect. So I've got a first question for you straight off the get-go. So I want to start with the macro view. So projections suggest that AI could cause data centers' electricity consumption to double, maybe even triple by 2030, which is not too far along. From your vantage point, how are these AI workloads fundamentally changing the energy demand compared to the traditional cloud compute that we're used to, that we've seen for the last decade?
Mm-hmm. Okay, so just when we talk about stats, I think from Adrian's presentation this morning, there's so many of these different sort of predictions and statistics out there. But certainly we know that data center electricity demand has grown significantly. And in Adrian's session this morning, he presented several graphs showing the global and the UK situation, so I won't repeat any of those points. We do know that AI workloads are categorically different from traditional cloud compute. So training large models and running inference at scale drives fairly high power densities compared to conventional IT. And this obviously forces us to rethink our traditional facility design. And we've also noticed that AI-driven demand is compressing timelines dramatically. So what used to be a 10-year energy demand forecast is now being consumed in 2 to 3 years. And then the pipeline of announced capacity globally continues to increase exponentially. So from a sustainability perspective, we've got new data center demand that is a significant driver, not just for renewable energy, but also natural gas, coal-fired generation. And unfortunately, we're expecting natural gas and coal to continue to meet over 40% of the additional electricity demand, at least until 2030.
Perfect. Thank you. I appreciate it. So also additionally, so we also often hear that the grid is primarily the main bottleneck for this transformation. Based on your experience with infrastructure projects, is the grid truly the wall that we are hitting, or is it covering up deeper issues with how we forecast demand?
Mm-hmm. So it is certainly a significant bottleneck. We know that grid infrastructure hasn't quite kept pace with demand. And in many markets, including the UK, data center operators are connecting to grids that were not designed for these load profiles. And that mismatch is creating real bottlenecks. So you can imagine that electricity availability and reliability shape and often restrict the deployment of large-scale AI models. Now, the rapid scaling of AI, moving toward gigawatt-class data center campuses, has created a fundamental mismatch with the slow multi-year timelines that we require to build and upgrade electrical grids. So on the one hand, we've got AI infrastructure that can be deployed in months, while the utility grid infrastructure expansion requires 10 to 15 years just to obtain permits and then to build. And so we're also seeing grid congestion, as we discussed this morning, in key tech hubs. And this has made authorities nervous, leading to various restrictions on new data center developments in areas across the US and Europe, like Dublin and Amsterdam. And this forces companies to either look for alternative locations or to use alternative technologies. And
Sure.
one of the things we know is that this isn't a temporary spike. The fundamental compute requirements of AI are expected to continue growing,
Yeah,
meaning
they
that
will.
the energy challenge compounds year on year unless there's genuine structural change in both supply and efficiency.
Fantastic. So for many of the operators in our audience today, they are focused on attracting hyperscale clients. What does the hyperscale playbook actually look like today regarding sustainability? Are we seeing a shift in what they prioritize when selecting a partner?
So we discussed this morning that hyperscalers are prolific buyers of renewable energy. And we've reached this situation where the large tech companies are operating at a scale that allows them to almost act like quasi-utilities. So if you're looking at your Microsoft, Google, Amazon, Meta, they are directly contracting for gigawatts of renewable generation. So they're financing projects that wouldn't otherwise be built. So there's that driver coming from the hyperscalers. And then also they're increasingly pursuing what we call vertical integration. So owning or co-developing
Yes.
generation assets, securing grid connection slots years in advance, and in some cases, even working with regulators to redesign how the market structures work. So a further factor for sustainability with the hyperscalers is that many of the jurisdictions in which they are headquartered tend to have fairly strict environmental legislation. So you've got the regulatory driver as well, especially in Europe. And then quite importantly, most hyperscalers have made public commitments regarding sustainability, particularly their decarbonization targets. You see this in their reports and in the media. And this means that their stakeholders will hold them accountable for delivering these goals.
So just as we built up upon for the public commitments, such as Microsoft's supplier code of conduct, for co-location operators, how much of the burden of proof do these commitments place on them, and how do their supply chains react to that?
So I think if we just look at the backdrop, we are seeing that these sustainability commitments are genuinely ambitious. And for the hyperscalers, they are strategically useful. Their commitments to net zero and 24/7 carbon-free energy, all of those pledges, they do serve to differentiate them with their enterprise clients and regulators. And they also tend to help them to lock in long-term energy prices and certainty through PPAs, for example. But what this means for their suppliers, especially, for example, colo data center operators, is that there are ambitious deliverables when you enter into a contract with a hyperscaler. And many colo operators are not aware of this, especially the smaller operators, and therefore don't budget for the cost of delivering these requirements. They're just so excited to get a contract with a
Of course.
hyperscaler. So you mentioned Microsoft Supply Code of Conduct. If you'll allow me just to focus, to zoom in on that. If you enter into a contract with Microsoft to supply, to deliver products or services, then there are 3 levels of commitments that are part of your standard agreement, because the Supply Code of Conduct is part of that agreement. So firstly, you are required to measure and disclose annually detailed greenhouse gas emissions data and calculations, and this must be verified through third-party assurance, in other words, audited at your own cost.
Okay.
Then the second requirement is that you also need to commit to a minimum 55% reduction in your greenhouse gas emissions across all scopes, scope 1, scope 2, and 3 of your emissions from your baseline year to 2030. And in this regard, you have to submit a structured plan to show how you're going to achieve this, and Microsoft tracks this annually. So that's the second requirement. And then if you're a large-scale supplier, the third requirement is you are required to adopt 100% carbon-free electricity by 2030 for any products and services provided to Microsoft. So you can see this is just one example of a hyperscaler where there are quite onerous requirements for all of their suppliers, but certainly for colo operators.
Especially for smaller co-locators, it's a very difficult demand.
Yes.
Perfect. So with the energy still the only conversation that matters here potentially, or are we seeing things like water scarcity, green building statuses, and socioeconomic impacts in emerging markets becoming genuine deal breakers?
So, I mean, energy is still dominating the conversations, particularly in the media.
Of
It
course.
focuses on grid usage, congestion, but we do see the discussions expanding. The energy discussions include renewables, obviously, and more focus on nuclear. Um, Apart from energy, of course, you referred to water. Water usage is becoming as scrutinized as carbon, and particularly with AI increasing the cooling requirements, hyperscalers are under growing pressure on water consumption for cooling, particularly in water-stressed regions.
Mm,
And this is also shaping site selection decisions
of
globally.
course.
Another sustainability issue you raised, green buildings. So a lot of focus on the use of sustainable materials for data center construction. So we're looking at the embodied carbon of materials also being required to be either reported on, or increasingly we've got green building certifications being included in contractual requirements. And then, very importantly, socioeconomic aspects. Adrian referred to some of these more on the activist examples, which you have in the developed countries. But I would perhaps add that when you're expanding into emerging markets, the socioeconomic tensions become more important, more significant, and focus more on investments in actual projects on the ground.
Perfect. So for co-location operators looking to win or retain a big AI contract today, what are the absolute non-negotiables? Is it just purely uptime and reliability, or is there another baseline that they need to account for?
Okay, well, I'd say the baseline is uptime. Even before we get to renewables and
Sure,
sustainability, you are required to have reliable power and it must be scalable. So power is the entry ticket. The hyperscalers
sure.
are not going to engage seriously with a colo provider that can't demonstrate credible, scalable, and ideally renewable back power supply with a pathway to hundreds of megawatts.
Mm,
So it is a bonus if you've got renewable energy backup, but certainly power is still sort of the baseline.
perfect. So how is the critical infrastructure, sorry, let me rephrase that. How critical is the actual renewable energy piece? So does an operator need to invest in physical on-site infrastructure, or are clients still satisfied with purchasing credits and RECs?
Mhm. So traditionally, the hyperscalers have accepted credits, but more and more what they're finding is what we're finding is that the renewable energy credits need to be substantive, not just cosmetics, not just cosmetic. So we call them RECs, renewable energy credentials, and sometimes you've got standard green tariffs. They're increasingly becoming insufficient. What the larger companies are expecting is some sort of additionality. So market-based certificates, they must be aligned. There must be some link between the credit that you've purchased or that you've got to what you're actually doing. And they're also looking, I see more and more, to transparency on the actual carbon intensity of the supply.
Perfect. So just shifting a little bit over to the physical side, are you seeing defined specs such as liquid cooling readiness or specific power water usage effectiveness targets? And are they becoming mandatory in the initial RFP stages?
Mhm. So, I mean, certainly the physical infrastructure specs have shifted. Colo operators are required to offer or have some sort of credible roadmap to liquid cooling ready facilities, high density power distribution. We spoke about prefab this morning, so modular deployment at pace is also critical. Unfortunately, if you've designed your facility even 5 years ago, it might already be architecturally limiting to current demands. We're finding that contractual and reporting alignment is also essential. Hyperscalers impose very detailed sustainability reporting obligations on your infrastructure. So colo operators must be able to deliver granular data. The data must be auditable on things like your PUE, WUE, carbon emissions, and even uptime. And often you need to deliver this data as near as possible to real time.
Of course.
And then, just one more point, there's fairly aggressive timelines. The speed and certainty of delivery now are increasingly differentiating. The hyperscalers will pay a premium to a colo partner who can commit to and deliver capacity on an aggressive timeline because the opportunity cost of delay is enormous for them.
Yeah, it's so high. And literally speaking about the premium costs of it, talk about the money side for the hyperscalers. There's a massive annual funding gap for digital infrastructure. So when operators engage with investors and lenders today, what do you think are those stakeholders specifically looking for in a sustainable project?
Mm-hmm. So I would say before we even talk about sustainability, the basic requirement for an investor is always that you have to have a, a good product, a profitable product. That's what they're
Yes, to make
investing
money.
for. Yes, they're there to make money. But what we are seeing is previously ESG was almost a tick box exercise. And I think that investors, lenders have moved well beyond that now. There's all
Yeah,
kinds of frameworks for green loans, sustainability linked financing. These are all becoming quite standard. And the covenant structures, in other words, the agreements, are tied to things like your PUE improvement. So, you get a loan and you'll get a reduced interest rate if you reduce your PUE or if you increase your renewable energy percentage. And even things like your emissions reporting, they all now carry real financial consequences if they are achieved and sometimes even if they are missed. And we're finding investors doing all kinds of things like stress testing your climate physical risk, having substantial audits, due diligence, particularly for assets that are expected to operate for decades in this very rapidly changing climate. And then just a quick thing on the taxonomy. If you're operating in European markets or even the UK, what you call things is quite important. So you need to sort of fit into these taxonomy frameworks. And yes, well, decarbonization is still very important for investors. So, and now it's not just reporting; they want to see a roadmap and they want to see
yeah,
milestones. And then always governance around sustainability under scrutiny. Investors want to see board level accountability recently, not just an ESG report, a glossy
sure.
report produced by a team. So we're also seeing that.
Perfect. And speaking of those investor contracts, they are becoming, as you say, more onerous. Are there more specific technical requirements or contractual pitfalls that startups and mid-tier operators should be wary of when negotiating these sorts of deals?
Yeah, I mean, we spoke about some of the kinds of contractual requirements with the hyperscalers. We're seeing similar requirements from investors, certainly around greenhouse gas emissions and reductions. Often we find contractual requirements for renewable energy. Some of the more onerous issues that I've come across, certainly the documentation requirements, especially the smaller operators, find them very onerous. You've got to have an entire environmental and social management system in place with your policies, procedures, plans on all aspects of ESG. When you get, funding from an investor, they have reporting requirements at least annually. They need data, they need documents, and similar to the hyperscale requirements, these have to be audited annually, usually at the company's cost. I would say, just as an aside, the most onerous contractual provision I've seen has really been where you've got a startup, late stage startup, wanting to get a loan and then agreeing to pledge their shares as security. And, I find this quite sad because for startups, that can actually mean losing your company.
I can imagine. That's horrible. Okay, just a slight pivot then in that case. So looking globally, where are you seeing the most instructive developments in how markets respond to this AI-driven energy surge, and who's getting it right?
Mm-hmm. So, I mean, we saw the graphs this morning. The US is moving fastest in terms of sheer scale. It is also running into the same grid constraints that we're all facing in other markets. Some interesting developments in markets like the Nordics, particularly Sweden and Norway. They've been attractive for their renewable energy abundance, the cool climate. They are starting to see some community and political pushback. The whole social license question is becoming more intensified. Southeast Asia, Singapore, certainly now that it's reopened after the moratorium imposed. Middle East also deploying capital, I'd say. Australia and Japan are increasingly important markets for AI infrastructure. So certainly all of the developed markets, we're seeing very rapid deployment and rapid growth.
Perfect. And is there a marked difference in how this plays out in the emerging markets like we spoke about previously? And are they able to potentially leapfrog some of the legacy issues we have in the West?
Yeah, I would say if we look at the East, for example, Malaysia and Indonesia are starting to attract massive investment. There's always the issue of water stress and grid carbon intensity. These are still material concerns that responsible operators must address. And then I do a lot of work in sub-Saharan Africa, and that is certainly the region is certainly emerging as an attractive location. A lot of development here, high level of skills, and the regulatory landscape is still in development, and I think that kind of makes it quite attractive for companies wanting to expand into these markets
and invest elsewhere. Of course, it makes sense. It makes sense.
Yes.
So when we bring it back to the UK, we've got a strong renewable history, but we also have quite a lot of notorious planning and grid challenges, as we all know very well. Is the heritage enough of a differentiator to keep us competitive when speaking about everywhere else, for instance?
I think the situation we're in now in any market is that you have to deliver. So, what you've done historically is not going to carry you very far. We're in, highly innovative period of time. So yes, you're right. The UK has a genuinely strong renewable energy story, wind in particular, and grid carbon intensity has fallen dramatically over the past decade. And that is a differentiator when the hyperscalers are comparing markets, if they are concerned about life cycle emissions, for example. But like you say, grid connection is still a huge constraint, and it is acute. We spoke about this morning, so I won't go into all of the stats. But the national grid's connection queue stretches quite far into probably the mid 2030s in many areas, and there's a backlog reform process. It is underway, but it hasn't yet unlocked that bottleneck at the pace that the market requires. And then apart from grid connection, the issue of planning, which we also raised this morning, it's also a major friction point. Data center development in and around London, for example, faces intense competition for land. There's community resistance in some locations. And then the planning system hasn't fully adapted to the speed and scale at which the sector needs to move. So yes, the government has signaled that data centers are critical national infrastructure that creates a framework for faster decision making, but just designating it as such doesn't necessarily translate into practical process improvements at the local planning authority level to make a real difference. So this is a genuine opportunity for the UK to position itself as a high integrity, well-governed market for AI infrastructure, leaning into its renewable credentials, the regulatory clarity, and of course the financial center status. But it requires coordinated action between government, grid, planning, and the industry itself.
And that communication right now is not so perfect, shall we say?
Yes.
Perfect. So we've used and relied on power usage effectiveness for a very long time. And now, given with the rise of AI, is PUE still a useful metric, or should operators shift their focus towards WE, embodied carbon, or even compute power output?
So for a while now, even before, Gen AI, PUE has been a useful efficiency metric, but for a while we've realized it isn't adequate as a standalone measure and certainly not an appropriate measure of sustainability or clean energy. And more we're seeing, well, I could also say investors are still looking at PUE as something that you do need to measure and you do need to report on. But the industry is moving towards using other metrics as well. So certainly carbon usage effectiveness is considered a very meaningful metric, so CUE, and increasingly looking at sort of 24/7 carbon matching rather than just saying annually, this is our renewable average. So, the carbon matching on an ongoing basis is a much higher standard to meet. And you've referred to water usage effectiveness certainly becoming almost a parallel priority, I would say, particularly because liquid cooling increases water consumption. And of course, there's various ways to look at it. You're not necessarily using potable water, but there's still the water issue around cooling. And particularly in water-stressed areas, we've got regulators, we've got communities pushing back on data centers. And I think, there's a lot in the media, that a lot of hype, and everyone's so scared about data centers, and especially when you link it to water use. So I think this is something that certainly operators should be measuring, reporting on, and looking to reduce. And then we spoke about embodied carbon a few times. That's the carbon embodied in the construction of the facility itself. That seems to be the next frontier that we're focusing on. So, I think operators are certainly starting to measure and reduce embodied carbon. And yeah, I would say ultimately the metrics that matter most are the ones that your clients, and if you have hyperscaler clients, then those clients and your capital providers, your investors are asking for, whoever your stakeholders are. And both sets of groups, clients and investors, seem to be moving towards more granular data. So, collecting very specific data across a number of metrics, collecting these more frequently, almost on an ongoing basis in real time. And there is also this shift towards independently verified data than what the industry has been historically comfortable producing.
I do see a question in the chat. I'm just going to quickly read it through just so I can ask it to you. So it's regarding grid delays. Are there any genuine innovation regarding on-site generation or long-duration energy storage, LDS? And would it allow the UK operators to bypass the queue and stay competitive? Good question.
Sorry, can you repeat the question?
Yes, no problem. I'm going to ask it just how they said it. So we talked a lot about how notorious grid delays are, but as we see any genuine innovation in on-site generation or long-duration energy storage that could allow the UK operators to bypass the queue and stay competitive?
We're not seeing it at scale at the moment. So we do see that, particularly with the hyperscalers, there's various innovations around on-site generation, either with renewables, or there's all kinds of things like bring your own device and then you have the generation on site. But like I say, the unfortunate thing is it's not happening at scale. We'd probably need perhaps some help from the regulators to have some sort of incentives around that. But that's where we are currently.
Oh, got one more. So this person's asked, for the planning constraints in the FLAP-D markets, are we likely to see secondary cities boom in the UK? And does the existing renewable infrastructure support moving data hubs away from London?
I think the short answer is yes. There's a number of different factors that you'd have to look at in terms of how these sorts of booms happen. The media and many of the activists are currently really quite opposed to data centers. You'll see in the media there really is quite a lot of anti-data center sort of media and sentiment. So I think this would be linked to some kind of lobbying if you're going to try and create centers, sort of secondary centers. But certainly from an economic perspective, there's a huge business case for it. So I would say yes, we haven't seen sort of something specific in terms of, it being an actual plan. But these could organically arise. In other markets, we are certainly seeing other markets growing, especially the emerging markets. I know from my work in sub-Saharan Africa, the data center demand is increasing exponentially, particularly from the hyperscalers who don't necessarily have facilities here.
Fantastic. And so finally, Sayuri, I'm going to ask for my own last question. So if you are a co-location operator trying to navigate this landscape over the next 3 to 5 years, what would you say is your best piece of advice to ensure sustainability remains the strategic advantage rather than just another compliance cost?
Okay, yeah, it's really difficult to say the next 3 to 5 years, but I
It's
would
changing so
say
fast.
yes. So the answer is adaptability and agility are
Of
going to
course.
be key. Like you say, sustainability wouldn't be just a compliance function. It becomes a core commercial and strategic imperative. And particularly if we look at the broader definition of the word sustainability, it's not just referring to environmental sustainability. You're looking at the whole system. Is it resilient and will it continue to perform? So you're looking at the social aspects, the environmental aspects, the economic aspects, all of the communities, etc. So, I think for operators, invest seriously in understanding your clients' sustainability requirements in technical depth. Hyperscalers have fairly sophisticated internal sustainability teams, and they tend to see through superficial responses very quickly. So operators who can engage peer-to-peer with hyperscalers will certainly have a higher level of trust, showing that additionality that you're contributing, doing the various reporting from a sustainability perspective that the hyperscalers expect, and then building the data infrastructure to support transparency, the ability to report granularity, as we spoke about, on your energy, carbon, water, uptime, etc. It's increasingly becoming that license to operate in the hyperscaler market. So it's much easier to build that from the start as opposed to trying to retrofit it when you're trying to win a particular client. And so, and then also in addition to all of this, I would say, if it's possible, engage with the policy conversation as well. Don't just react to it. We're very quick to criticize governments or specific markets, but we can actually, as part of the economic and business community, engage and steer the conversation and steer the decisions in a particular way as well.
Fantastic. Those are all the questions I have for you today, Sayuri. Thank you so much for your time. It's been really appreciated.
Thank you. Thank you, everyone.
Thank you so much. Cheers. Thank you.